Robinson Helicopter Company has taken one of its most popular helicopters and transformed it into something very different. The new turbine truck version of the Robinson R66 removes the pilot entirely and turns the aircraft into a fully autonomous cargo helicopter. Instead of carrying people, this machine is designed to handle missions that are too dangerous, too remote, or simply too repetitive to justify putting someone in the cockpit. To make that possible, Robinson is working with Sikorsky, part of Lockheed Martin, bringing Sikorsky's Matrix autonomy system into the aircraft. One of the biggest changes is right at the front. The traditional cockpit has been completely removed and replaced with large clamshell cargo doors. These doors open wide, making it easy to load supplies directly into the aircraft. Instead of carefully packing cargo through a small door, operators can simply roll up with a forklift and slide a pallet straight inside. By removing the seats, flight controls, and other systems needed for a human pilot, the helicopter becomes lighter and more efficient. That change actually increases the useful load to about 1,500 pounds. When you combine fuel and cargo, slightly more than the 1,420 pounds the manned version can carry. With certain modifications, the utility configuration can reach a maximum takeoff weight of around 2,900 pounds. Under the skin, though, the helicopter keeps the same reliable power plant. The turbine truck still runs on the Rolls-Royce RR300 turboshaft engine, the same engine used in the standard R66. It's known for being lightweight and dependable, which makes it a solid choice for this type of mission. Performance remains impressive as well. The aircraft can cruise at about 120 knots and stay airborne for up to 4 hours, depending on the task. Its compact size and familiar two-bladed rotor system also allow it to operate in tight or remote areas where larger aircraft would struggle to land. Using the system is designed to be simple for operators. After loading the cargo, the operator opens the Matrix tablet interface, enters the mission details, and the aircraft handles the rest. The autonomy system manages flight planning, navigation, obstacle avoidance, and landing using cameras, sensors, and onboard algorithms. No one needs to physically control the helicopter during the mission. At the same time, remote piloting is still an option when needed. Another advantage is that the Matrix platform uses an open architecture, meaning new software features and capabilities can be added later without rebuilding the aircraft. Sikorsky has already logged more than 1,000 flight hours with this autonomy system across several aircraft types, giving it a strong level of credibility. The potential uses for a helicopter like this are easy to see. It can deliver supplies to locations that would be risky for crewed flights, run repetitive logistics routes, or reach areas where building roads simply isn't possible. Military operators could send it to deliver water, fuel, or medical supplies to the front lines, without putting pilots in danger. Commercial operators could use it to move cargo to offshore oil platforms, transport organs during medical emergencies, support disaster relief operations, or handle routine supply missions to remote industrial sites. Because the aircraft is less expensive and designed for simpler operations, it could be deployed in large numbers and used in environments where losing a traditional aircraft would be a much bigger problem. Development is already moving forward. Robinson is aiming for the first flight of the turbine truck in early 2027. The helicopter airframes are built in California, and then integration work with the autonomy system takes place at Sikorsky's facility in Connecticut. Interest is already coming from both military and commercial sectors, including potential roles as unmanned aerial targets and support aircraft for oil and gas operations. Robinson's vision for the turbine truck focuses on economics and scalability. Rather than competing directly with larger autonomous cargo aircraft, the company sees it as a smaller, more affordable option that can operate alongside them. A helicopter like this could eventually become part of large autonomous logistics fleets, quietly moving supplies to places that are difficult, dangerous, or simply inefficient for human pilots to reach.